All right. Welcome again to our third webinar in the introduction to event sourcing series organized by EventStore. I'm Alexey, and I'm developer advocate at EventStore. So today we're going to talk about projections and read models. So during the previous two webinars, I hope some of you attended this to you. So we talked about event sourcing in general. That is a persistent mechanism that allows you to kind of avoid impedance mismatch and store the intent of your users in the database, unlike in a state-oriented persistence where you do not do that. You basically just manipulate the state of your objects. So the life cycle of your entities become event streams. So there is one issue though, and that's what we covered in the second webinar, that event streams are very hard to query in terms of like if you want to retrieve some ad hoc data, the current state of your entities based on a certain query, which might not involve the key of the entity, the identity. So you get in trouble because basically it is possible, I have to admit that, but it's not easy to do. So therefore, CQRS separating commands from queries gives us a way to handle commands in a way that commands work with the domain model. So commands are sent to the application service or whatever you use to receive commands, and the application service calls your domain model. And the domain model generates new events to get persisted to EventStore, and then everything stops. And this is fully consistent because there is no, you operate on EventStore, you always retrieve the latest state of your entity or aggregator in a sense. And this guarantees that everything you do on the command side is fully consistent. And all the rules are enforced and you completely safe. So what about queries? For queries, we need to do something else. So the easiest ways to do queries is basically to project events to a store, a database that allows you to query data easier. So like in traditional database. So in the previous webinar, I was showing some code to project events to RevenDB. It's just an example. So it's the document database. You could just as well project a relation database, and you could project a search database like Elastic and cache and stuff like that. So whatever you want to achieve by kind of showing information to users, you can engage projections and query events, not query events, but query the current state of entities that were projected. So today we're going to touch upon a bit of so why the whole webinar is just about read models and projections, because it's quite a big topic and there are a lot of confusion and a lot of questions that I hear everywhere, asking about eventual consistency, asking about what do you want to, what kind of state you want to keep in traditional database, so stuff like that. So let's talk about it. So I'm in a bit different setup now. So my green screen doesn't really give much of the benefit today. So, but I have a proper whiteboard. So I'm going to try and if I can connect my proper wireless microphone, I will try to kind of explain you with some diagrams what I usually mean by that. By when I tell people that you need to be careful with what you project and what you really want to keep in a sort of traditional database, and what kind of other patterns you want to avoid in a sense. So I want to show you a picture of or diagram that illustrates a simple projection that that doesn't do anything fancy. It's just projection a state to a state from two different aggregates. So this is already something that I personally didn't do when I started with event sourcing. Let me just open it in preview. So when I started with event sourcing years ago, when I first hung out with Greg and learned a bit about a pattern and I like it, I couldn't go away from the from this urge to have entity state, my aggregate state, projected somewhere so I can look at it, because it's very hard to look at the current state of an entity by looking at the event stream, at least until you kind of get used to it. So, I'm not sharing my screen. That sucks. So, and what I've done, basically, EventStore has this brilliant feature that led me to this pattern. That's called the category stream. The category stream is, for example, you save an event to a stream that's called, in this case, for example, shopping cart or order, in a sense. So it's called an order here. So it takes this part before the dash, and so you can say order 1 to 3, order 3 to 5, and it looks at the dash. And after that, it will create, it will have a sort of virtual stream that's called a category stream. It's named like $CE dash and then order. And all events that concerning about all orders in the system will come to the stream. It's very useful. It was useful for me to subscribe to that stream and project all order events to sort of representation, the current representation of an order. I'm not saying this is anti-pattern, though, but it might be, because if you just do this, you lose 80% of the value of projections, because projections basically not limited to project for a state of a single entity. So it took me a while to realize that I was doing things a bit wrong. But then I came to a picture like this. For example, I have two different streams. One is the order stream, another is a payment stream, and they share the same ID. Like this could be GUID or whatever. I use just readable int. In this case, it means that they are correlated. They concern the same order, for example. So the payment 1 to 3 is payment for the order 1 to 3. So what happens is, and I have a single projection. So the projection in this case creates a document when I add an item or I create a new order and stuff like that, and it updates it. So it's very traditional style of manipulating states in a normal state-driven database or state-oriented database. So this is the projection. It's taking events from two different streams and consolidating them in one place. So, and then you have a read model that gives you the order overview, including the payment status. I'm not saying that you should do it like this. It's just for illustration purposes, because you probably need an event that's called order paid or something like that. It's just an illustration. But I hope you get a gist of it. That's there is a lot of value of listening to many streams and projecting event or streams for multiple entities and project to a single document. So during the last webinar, I mentioned that most of the time, or in a lot of cases, events need to be ordered. For example, you would never expect a payment to be requested until order is confirmed. Therefore, you're looking for a place which is called sort of, I think it has a name, but I would say that this is global, what's it called? Global sequence of events. So EventStore, for example, keeps, writes all events into a single place, basically append only. And it writes it in a chunk and then starts a new chunk when it reaches the size of 2 gigabytes. So it forms, since it's event only, it's basically just one gigantic stream of events. And all these things, like this one, it's a virtual thing. It's not a real thing that you would go to Event Store and you can see it in user interface, but physically it's just an index that's put by Event Store on top of the global event stream. So if you subscribe to that global event stream, you will get all events in order. It's in order that as they appeared in the system. So this gives you a lot of power, because then you don't need to think about what do I do if, like how the hell the request or the payment received before order has been even confirmed. So then it solves a bunch of problems. So we usually subscribe to AllStream when we need to deal with projection, but it could create problems if your event stories under heavy load, and then you have a lot of several applications, for example, writing to it. It might look as a shared database. We can discuss that later. So I personally see a lot of power in this. So let me just close this one. And if we look at this case, for example, if we look at how, what kind of value we can get from it, we can go beyond, for example, just correlated entities by order ID in this case. And I gave an example during the previous webinar when we were partitioning the read model. Basically, the read model identity was the customer ID. So you can use whatever as a basis for your document. So in this case, I give an example that you have several event streams that are for different orders, but they are for the same customer. And then you can create a document that represents the customer order overview. So it has, it listens to the old stream again, and then consolidates them or partition them by customer ID, and then creates a document. And this document will have an ID of a customer, right? So if you want to show the order overview for a single customer, you don't need to query all orders by customer ID. You just can go there and fetch this document by identity. And it takes literally no time to do it. So instead of, it's basically converting the paradigm of creating aggregated views. So in a state-managed or state-oriented system, what you would do, you have orders scattered around in a huge order table or whatever, database or document collection. And then you will query it. And every time the customer order views it, you need to retrieve this. You need to execute this query. You need to create an index by customer ID. You need to have something that actually supports, if your order table becomes huge, then you probably get into trouble with the performance and stuff like that. And from my own experience, for example, using e-commerce, it's, for me, for example, I order much less than I look at an order, because I want to check the status. For example, hasn't been shipped. What is the tracking number? Where the hell is it now? Is it back ordered? Or what is the estimated delivery date? And stuff like that. So for each order that I make, let's consider it right. In terms of reads, I have much more reads. So like for each order I place, I have 10 reads at least for that order, maybe more, depending on the life cycle. If the company is not fast enough delivering it, I will look more on that and maybe cancel it. So instead of submitting a lot of queries to that huge storage of huge collection of orders, I would have a consolidated view, which is aggregated by my ID. And every time I go to my order list, I will just go straight to a single document, fetched by ID. It takes no time. It's very fast, very optimized. It can be primary key if you wish, or document ID, and then you just get it. So this is what we discussed concerning the read-write mismatch, because it rarely in systems for each write you have one read. You basically have either one way, you have much more writes than reads, or other way around. So I want now to try to switch to my drawing board. Switch. All right, I'm really sorry about this glitch. Yeah, that's the problem of doing it from home, right? So you're not properly equipped. At least I have the whiteboard, but it introduces some new glitches. So what I was saying, and I probably got lost in the flow, that the user over here uses the information that they see on the screen over there, the information from the real world, and their brain, if they have one. And based on these three sources of information, they make decisions. And decisions are represented as commands because users usually do something with the system. Otherwise, they're just looking. So it's sort of Instagramming, right? So then you don't need anything. Maybe you just need a read model. You don't need a brain. You don't need information from outside world. Maybe you do. So even there, even in Instagram, you have a command called like and comment. So you have some intent and you want to express it. So express it is a command that goes to the domain model in term. And domain model processes this command and say, okay, this Instagram is locked, or this photo is locked for comments, so you cannot do that. And maybe Instagram decided to not give you the possibility to like the photos, so you can't like it. And if everything is fine, then this domain model produces an event. So what I was saying, that events are then get projected to the read model, so the cycle repeats. And Alberto used to call it, maybe he still calls it, the picture that explains almost everything. And I added one bit over here because events can also be used as they convey the information. They have something inside, the properties that explain what happened with the domain model. So the state transition, the domain model is now in a different state. So this state transition represented as an event can be used for something else. In particular, it could be used to talk to another part of the system. Let's say this reaction lives in a different box, and it will emit commands as well on its own. And this command will be used in another domain model or another part of your domain model in the same context to do something else. For example, if the order has been paid or shipped, then you usually get an email. It might be direct reaction. No, it couldn't be. So there is some sort of email service over here that listens to this order paid or order shipped events, and then it sends a command out, send an email. That's a simplistic thing. Or if you think about payment processing, so for example, okay, you have a confirmed order, it hasn't been paid, payment request sends to the payment processing system, it shows you the credit card screen or whatever else, so maybe sends you an email, and then let's say it's a long-running process, so it doesn't happen directly on the screen, it goes to the invoicing system. Okay, there is a confirmed order and it's paid by invoice. So, and it needs to be prepaid. So I send an invoice, perform my invoice to the customer by email. So the whole bunch of stuff happens. There is still an updated read model over here that the customer gets information that the order will be invoiced, so you need to pay us. And as soon as the customer receives this information, again, they use information on the screen, information in their brain, and money on their bank accounts to submit another command, maybe even outside of that system. For example, they go to the bank, online banking, and they make a payment. So this cycle repeats on that outside of our domain, outside of even our organization. But somehow we get information from our bank from outside of the world. So there's another box over here that's called external system. That doesn't produce commands because they just tell us what happened outside of our control. We could not say, "Hi, you telling us that they paid us? No, we don't believe you, so just go away. We wouldn't do anything." This happened to me, but it
shouldn't happen in proper system. So external systems basically produce other events. And this event might just be as well represented as a read model for the sake of integration. This is how a lot of anti-corruption layers are done. So translate the language between different contexts into your own language and use it, store it somewhere and use it as a read model for queries. So you know what's happened outside of your control. And then this information is shown on the read model, and maybe it's to trigger the reactions. For example, we received an event over here from external system saying that order has been paid, or we just received money. So it could trigger a reaction, for example, reconcile against open orders if there is a description or invoice number. And when that happened, we send a command again, and it goes to the domain model, and it produces an event, for example, order paid, and it goes back to the read model. So this cycle continues, and it happens. It doesn't matter if we talk about event sourcing or not. It happens anyway. So it just might be implicit, like with state-managed systems and a lot of service calls back here and back again and sending XML files. It doesn't matter. What matters is that this cycle continues all the time, and if in a physical world as well. With event source systems, this cycle becomes much more explicit, and with CQRS. So you have an entity that, or the object, or whatever property bag that's called a command. It goes to your domain model that processes it, emits an event, and there is explicit reaction that does something else and sends a command, and so on. So here, what I meant is that the picture that I showed you previously, like one projection for order, for a single order, including the payment status, it doesn't need to be done like that. So I would apologize, because it's just an example, so don't kill me for that. What you should be doing, actually, if the payment gets processed in the payment stream, you get this event, you trigger a reaction over here that would tell the order to say order is either partially or fully paid. So, and then you can project it to read model, whatever, how it's called, order view, that contains all this consolidated information. Here is the order itself, and this is the payment. So that example was just to demonstrate that you might sometimes listen to events from different entities. And just over here, I was demonstrating this. So remember, those of you who attended the first webinar, I was showing this as an example. This, not this, of course, but the screen of Amazon, for example, consists of several parts. So how we usually do that? So this part, for example, is the debug. This is rarely changing information, so we can we have this sort of master data or book repository over here. So if we need to retrieve this information, we go to that place. This is maybe the what's called reviews. This is something else. So this is maybe not the best example, because I was showing. Let me just say this is maybe customer details. This is the order header. These are lines or whatever. And if you split the system kind of hard enough, really hardcore, it's not, again, I just lost examples. Maybe it's not the best example, but sometimes what happens is that a bunch of microservices over here, over there, and over there, and the UI needs to go either to the backend front end and fetch all this information in 3 different API calls, consolidate it in API, and then we'll send the result back, consolidate result. Or you do it in the front end, or you use micro front end for this crazy web components, and a lot of stuff happens. So if this information basically belongs together in terms of that it's always shown together, all this stuff, so all of it, then you might just as well, instead of doing that crazy stuff, you can create a read model that consolidates information up front. and then you just can show it on the screen. So you don't need to do anything. You just have a screen with 3 parts, logical parts, still good UX to separate them, but they're coming to the screen as a single read model, information from a single read model. Let's say it like this. However, there are situations when you shouldn't be doing that, and this is where Matt called me. So, for example, you have 3 parts of the screen. This is the order status, and this is kind of important stuff. This is picture, and maybe it's not that important, but still you want to see that. And it's basically maybe in CDN, so you don't need to think about it. It's just a URL. And these are recommendations. This is closer to Amazon. So what happens? First of all, recommendations have a completely different life cycle, and they change every time. So because it's the influence to the recommendations is a lot of different things going on outside of anything that's related to the order. So then you wouldn't do that. So why would you update personalized recommendation for that particular order, for that particular customer every time that sometimes happens outside of everything that relates to this order? It's just madness. I mean, it will drown in all these updates, and it's completely unnecessary, because there the balance will shift towards writes. So there is a massive amount of writes and just a little bit of reads. So like, let's say I looked at this screen 10 times for the life cycle of the whole aggregate, but here it can happen like hundreds and thousands of times per second or per minute. So if you happen to have that kind of system, you don't want to consolidate everything for a single screen in a single read model. Then it becomes an anti-pattern. And especially if this recommendation service, for example, is not reliable, or, I mean, let's say we separate it. Okay, so what do we lose? We say if recommendation service goes down, then we couldn't show the recommendations. Okay, who cares? Do you want to see that? I actually get more annoyed by seeing it. Sometimes it's useful, but not all the time. So let's say you got this screen, all right? So would you be happy? I bet you would, because then it's just everything you need to know. So having use case-based projections is a good practice. However, if there are some completely alien concerns, so recommendations have nothing to do with the order and maybe something else, you don't want to combine them. Keep them separate still. You have a chance to consolidate information that is relevant for that particular use case. So the use case would not be to see the recommendation. The use case would be to see a bloody order status. So this is what I want to do, and this is what it probably can consolidate. One thing where it can become a pattern again is, so basic, is when sorry, I need to find it. Oh, here. So this is an example when you want to consolidate things. And in this example, I was looking at situations when you'd rather have stale data. Well, okay, let's go to eventual consistency first. So one of the questions that people ask is, what about eventual consistency? And eventual consistency seems to be a very sort of touching topic. And I read an article recently saying, how comes that from the world when we took ACID for granted and everything is consistent, we suddenly say eventual consistency is fine everywhere. It's sort of magical dust. You put it there and you solve all your performance problems. Well, I guess this person who wrote this blog post is younger than me, for example, because I never took full consistency for granted. Because if you remember the times when everything was done on paper, systems were never fully consistent, because you basically send to the government office a letter and then you wait 1 month for a response because they exchange letters and all their systems are not consistent. And in some countries, correct me if I'm wrong, Matt, in the UK it was like that a couple of years ago. And in Italy, it's even worse. Alberto told me crazy stories about things like social security number could be duplicated in different provinces. So, I mean, is it good or not? We can argue. In most of the cases, it's not. But this is how things worked before, and humanity had hundreds of years, or maybe thousands of years, dealing with eventual consistency. Of course, we want to see our data faster. And still, I remember that I used to be a Lotus Notes developer before, and I actually took eventual consistency for granted because that was my life. So I have a server in one country and another server in another country, and they were replicated by schedule. So they replicate every 5 minutes. So by definition, everyone who sits in a remote office, they would see data five minutes later. And if they've replicated over ISDN 64 kilobit internet connection. And it was going down from time to time. And still, you see, nobody died. I mean, at least in the industry where I worked, and it was finance. So I'd say, I wouldn't say full consistency overrated, but at the same time, the amount of time that people spent to solve this problem sometimes doesn't justify the use case. So dealing with eventual consistent projections is it's an interesting topic because I didn't think about the concepts that much that it needs to be. So I used some sort of heuristic, like how fast the users would see it, how fast we need to be real time, but it's not giving you sort of quantitative justification or whatever. You can write down and just say, okay, we agree on that. And I heard this from Eric Evans recently. It's just a service level agreement. So when we deal with that type of with eventual consistency, I can give you an example that I always, probably some of you who heard my talks before remember that. So we were building an EventStore system, and one developer came to me with tremendous technical problem. He said, this is eventual consistent system, and I need to ensure that the project number, which is a property of the project, so it's not an ID, it's just an arbitrary number, must be unique. And remember, uniqueness of usernames comes all the time when you discuss events or systems. All right, it must be unique. Okay, what happens? So he said there is a chance that if you don't project fast enough, so in that 10 milliseconds, there could be another one that's going to enter the project. And okay, what is the chance? Okay, how many projects get created? I'd say maybe one per minute. Okay, so the chance is pretty low, okay? And then I said, do you talk to the business? What will happen if there will be 2 projects with the same project number? I say, no, I didn't. Well, there is a requirement. I read it in front of me and says it must be unique. Say, okay, step back, go to at least the business analyst. Maybe you don't have access to the customer. Go to the business analyst and ask them. So he came to me next day and say, I talked to them and I say, it's not important at all whatsoever. It's nice to have, but nobody dies. I mean, if there would be such a situation, it's very easy to fix or not even bother because nobody cares. So for me, this is an indication that sometimes we as developers don't want to look at the reality. And I know that we don't like to talk to domain experts. I know that we prefer to deal with requirements, but this is not what domain-driven design, for example, teaches you. Domain-driven design tells you, talk to bloody customer, know your user, know what they're doing, understand their problem. So in many cases, in a lot of cases, I know about, I want to see my own rights. But that's not always how systems work. For example, if you, I have a smart home system, for example. Yeah. So I click to turn off my kettle in the morning. I click a button. I really want it to turn on, but if it turns on a bit later, like in 10 or 2 seconds, that's how the Z-Wave protocol works. I don't care. But some situations require different SLAs. So what Eric said is that you need to go to the business and discuss with them what kind of SLA you can tolerate for that particular information to be stale, because we prefer not to call the read model inconsistent. We prefer to call it stale. Here is the example on the screen. It stays there for too long. I need to get back to it. That I'm projecting from 2 different streams to 2 different read models, and I want to consolidate information from 2 different read models on a single screen. So it's okay, as I said, it can be useful, but in this case, what could happen? So for example, if order status has its own projection and it's awaiting payment, and then we got a payment received, and we projected 2 different read models. One of them is a payment status, which says processed, and another one is the order status that needs to become paid. Again, from domain perspective, horrible example, but just bear with me. This is, by definition, some sort of a system that can have transient failure. Basically, any system can have transient failure, but this is a delayed write. So we wrote our event to the event store, but does it guarantee that it gets over to the read model straight away? And it could be a network glitch over here that just doesn't allow this projection to work. So suddenly something happened and there is an error over here. And we didn't do a retry, so we just failed and our projections move on because it's a bad practice for projections to crash. So what happens is that we see that our order status is awaiting payment and there is a payment associated with it and it's called process. If we show this to the user will be damn confused. That's just the way how different part of the system combines sort of out of order. So processing events not as they should could lead to very big confusion. I give you another example from vehicle tracking, because we did a read model that represents the object state, and the state could be either it's moving or it's parked or it's idling, for example. And we have another read model that projects the location of the object, and the location changes real time because the device that installed in that object or the vehicle just receives GPS signals and sends over the location. So if these read models come out of sync and we combine them on a single screen, for example, the map. So there is a vehicle that shows, for example, gray because it's parked, and suddenly starts to move on the map, being parked. It confuses a lot of users, really a lot of users. So in this case, the SLA is not to have, for example, millisecond delay in projecting events, but events that you project needs to come in order, and it's rather preferable to have a read model that is stale, but it's consistent in terms of the information that it shows to the user. For example, if the car started to move and we don't project it yet, and because we didn't catch up, and we started to move this icon on the map in a minute, at least the state of the vehicle that is moving and the location start to change at the same time. So sometimes it's more important to keep the information in the read model consistent than trying to optimize it and prefer immediate updates. So this is important to remember. There are many use cases where you need to trade one side in order to, for example, trade performance, but then ensure consistency on the read side. And even if it's stale, nobody cares, to be honest. So this is just something I want to share with you. So I had another thing about the let's see. No, not this one. It was about projections. So yeah, this example that I showed at the start would solve this issue, because what it would do, it just projects to a single stream instead of projecting to, or a single read model instead of projecting to two different read models. And therefore, the state, because events come in order, the state will be always consistent. So in order to, there is one more thing that I want to say, or a few of them. Just look at the time. Be good. Maybe I need to return to the drawing board. So that thing is about projections idempotency. So take some time to move. It's another corner. Let's say, so how projections work. When the application starts, first thing it does, it's kind of workflow, right? So the startup flow. So there is a database, there is an event store over here. It's a database. And there is, for example, one or multiple databases. This is Postgres, and this is Mongo. And your application starts. So, and you have, in the application, you have a couple of projections over here. And one reads from here and writes to Mongo, and another one reads from here and writes to Postgres. So when the application starts, first thing it does, it goes to, let's say you have in Mongo, you have this order overview. And you have also a collection that is keeping checkpoints or offsets in Kafka world, we call checkpoints. And the checkpoint collection contains, for example, a document that's called order overview. And it says that the last known checkpoint for this projection is something like this. So 101,028. So when the projection starts its work, it goes to the stream that it listens to, for example, the all stream. And it asks to start at 28. And it projects all events, it goes. And so if you don't have a lot of load, so what you do is that you receive an event and you sort of project to a database. And the second step, at the first step, and then you update checkpoints. So let's say this event has a sequence number that is 1001,029, and then the checkpoint gets this number. And then you get 30, and then you get 30, and then you get 31, and so on. And then the application stops, and then pick up the latest one, and then goes further. As I mentioned on the previous webinar, some databases allow you to do this transactionally. So imagine if this is the not collections, but tables. So you have one checkpoint table and one order overview table, and then you open a transaction over here, and you update the document and update the checkpoints at the same time. Not always it's useful. So updating a document in Mongo, for example, it's a fast operation, but it's still, for example, you have a cluster, the cluster needs to have a consensus. If you have a proper consistency guarantees. So it needs to replicate at least to some nodes. You can have settings, doesn't matter. But still, this operation takes time, even if it's very small. And some stores do not have transactions. So for example, and you end up with two-phase commit. So you do one, and it's green, and the second doesn't go. You could also say my read model in a, or projection, it has so much load that I would say I would only store checkpoints for every 500 events or 1,000 events or 5,000 events that I process. It's perfectly fine. It will save you some CPU cycles and will save you I/O, and I/O there is important. So, but this is a problem, right? So your checkpoint didn't move, and then the next time it starts, it doesn't start here, it starts here. And then it will reproject events that are already there, that were already projected. There was a question about this in the first webinar or in the second, I don't remember. Why projections need to be important? Why do we need to avoid calculations there? Because if you have like plus 25, or so let's say total equals total plus event dot amount, and this happens twice, then you had, for example, before you had a total of 100. So first time, what happened is and the event gives you 25, for example, you get 125. And eventually, if this glitch happens, you end up with 150. And this is invalid. So then your real model becomes invalid. It has invalid state. So therefore, I really recommend to avoid this kind of things and keep projections are important. Otherwise, it's very hard. There is a way to solve this, though. So the way to solve this is rather simple. And you might use this if you cannot avoid making your projections. You cannot afford making a projection that important because you just don't have enough information in the event, for example. So what you do is you emit an event from the aggregate. And the aggregate has a version, right? So let's say it's 26. And then the event would contain a meta, let's say aggregate version equals 26. And then it comes in the read model. And somewhere over there, there is a property that says that the version is 26. And then if it comes twice, so one time, so we say it's 26. Okay, yes, and then it's 26 again. And you say no and don't process it. But there is a problem with that it only works for this particular aggregate. If you bring another one over here, that is aggregate number 2, and it has version 2, and you combine them in a single projection, that's kind of what version is this? You need to keep all the versions. That's kind of crazy. So this is why I would say this is easy to do, but again, it's not always relevant. You can easily get to the situation that it just doesn't work. If you keep the global event stream version in your read model, then it might work. Not all stores support it, so just be aware. This is getting technical. So it might work, it might not work. So let's get to the SLA thing again. So let's say you have a pre-agreed SLA, so you have your events in a stream, and they get projected. To a database. All right, and projection is not that fast, so it kind of sometimes it struggles. And let's say your last event is 2000 whatever, arbitrary numbers, but your checkpoint here, so the projection keeps the checkpoint, and it's somewhere around 100,000. So you have something that we call a projection gap. And this I need to write in big red letters. And what do you say in London? Mind the gap. This is the gap you need to mind. And this tells you a lot about your SLA. So in this particular case, the gap is 1020, whatever, 256. It doesn't solve your SLA though, because what is this number in terms of time? And you don't know. So projection gap is important because if it keeps growing, it's a good indicator that your projection is lagging behind. So your eventual system becomes very stale, and eventually it becomes not very consistent. So people will struggle understanding because they don't see their own rights. What is that?
I don't get it.
Ah, you don't get it. It's Siri. Shut up. There are indicators that can help you solving this problem, and these are well-known things from just a normal, good old distributed systems. So, a couple of things you need to keep your eye on, and these are lead time and critical time. So lead time is what it takes to get from here into there. In terms of projection, it's just as relevant for messages. The critical time is all it takes for the user to put stuff in the system all the way that it can be seen somewhere, or it can be robots or whatever, but let's imagine a simple case. So, and this is your SLA. So it can be either one of those or both. And this is what you need to watch. These are three very important indicators that you need to take care of. Mind the gap, mind the lead time, mind the critical time, and this tells you about if you're meeting SLA or not. And if you're setting up metrics, then you really need to set up alerts up front, so it's a little bit less than your SLA, and if you're getting closer to not meeting SLA, you need to call someone. If you're over SLA, you really need to call someone, even if it's the middle of the night. So it's not hard to do, because basically what you need to monitor is the checkpoint position and the last event number on the stream, compare them. Lead time and critical time are also easy to do. So for example, every event has a bunch of properties over here. Like this is data, and we have meta. Some stuff EventStore, for example, does for you. It has a timestamp when an event was written. This gives you the indicator over lead time. For critical time, we can just add some meta, let's say the command timestamp. Some say it's not a meta, it's actually business because it's SLA, right? So then some of you might have been in our hands-on with Sergio, and we used to have this properties on events that's called, for example, let's say I changed the order. Well, I know I added an item, so item added, and it has some data, blah blah blah. And in this case, to measure the SLA, this and for other concerns, You could say added by. So you say this is your username and add it at, and this is the timestamp. And this is the indicator of critical time. So it was there. Usually it comes not from the moment when you write an event, it comes from the moment the user submitted the command. So you can measure that, and don't underestimate metrics. In eventual consistent systems, you need to know when things happen. You need to know when you're lagging behind. You need to know the speed to recover. So you can calculate this, the processing rate multiplied by your gap will be the problem, the time you spent out of bed in the middle of the night, watching the system recovering. So these are things to remember. Another things that you might need to be careful about is that you really want to know what's going on in your system. And I don't want to draw anything. I just mentioned one thing, and I will just write it down. It's tracing. And not just tracing, but distributed. I don't know your experience. We have wide audience with different experience. I would say if you didn't do that, do that. Look at OpenTelemetry. There is a new standard, emerging standard. It's out of alpha. Hopefully will be out of beta soon. There is established standards like OpenTracing, and there are a bunch of libraries for all languages that exist. And there is automatic instrumentation for various of different languages and environments, JVM, CLR, whatever. And popular libraries like I'm in C# space, so I know that ADO.NET, HTTP client, web APIs, everything is automatically traced. Redis, MongoDB, SQL Server, and a bunch of contributions to do that everywhere. And in my practice, that happens a lot, because what happens is you have a bunch of stuff happening everywhere in different places. Just me. Try to scroll. Nah, okay, doesn't matter. So you have an event and you have projections here. And projections right to different databases, and it could be a lot of them. Because make no mistake, as soon as you move to event sourcing, you make your system somewhat distributed, even if it's a monolithic system, because it goes through sort of messaging pipeline when you store events. And you need to know what happens in all these boxes. You need to know how long it takes to write to this database. You need to know if there are errors, error rate is increasing or decreasing. You need to know the rate of things. And if you do distributed traces, it draws you the nice flame graph, for example, Datadog, that you have. This is the write. This is the subscription, and there is Mongo. And there is a message bus here. And there is some stuff, and it could be like I saw flame graphs for like over 1,000 different operations going across multiple pieces of infrastructure. It gives you a lot of visibility in terms of how your system behaves, and it's very valid for projections, because projections are asynchronous and eventually consistent. So by looking at the flame graphs, you can easily detect glitches and see if there's any trouble and you want to improve something. So for example, if you're writing a checkpoint, it takes more time than updating your read model, then probably you're in trouble and you need to optimize the checkpoint store. So the last thing I want to talk about is splitting the system a little bit with projection. So that is not required, but you can still do it. And it can give you a bit of power. And sometimes it's required to do. And I want to show you why. So that was an error. Yeah, this, for example. So sometimes you want to go to microservices because your boss likes it, you like it, you want to improve your CV, or it's a requirement. So when you do that, you can, for example, start by splitting the read side out. So projections are very independent because they do not depend on anything else in your domain model except of the event contract. So as soon as you can share your event contracts, and it's safe to share because they live inside the context, this is a context boundary. This is the same language, so you don't do any translation, and you keep control, but they still can be independent components. So there are two sides of it. First of all, that you might just as well, for example, phase out this projection because it's, or plan to phase out and create more optimized version of it. So normally what would you do, you need to first create or say, okay, from this moment on, I update my schema in a SQL database and it will be different. And I need to change the APIs if I need to do that. And all the consumers will need to follow, and we have a big embedded release. So what you do instead is, for example, you create a small projection on the side that writes to a new database, and you just let it go. In a couple of days, or maybe in a couple of weeks, depending on the size of your event store or the number of events it needs to process and the speed of the database, it will eventually catch up, and you get a brand new structure, new schema, a read model optimized for a different purpose. You put the API on top of that, but hence you haven't touched a single piece in the existing system whatsoever. You just created a new thing, a new brilliant search mechanism or whatever else, completely on the side without affecting anything else. This gives a lot of power. This is really cool because then you put an API on top of that and they say, okay, ladies and gentlemen, I have a new brilliant thing and you can use it if you want. And if you don't want it, I will still shut it down in 3 months, but it gives them time to migrate. So you avoid big bang releases. You have a lot of time to test. You do it in production if you want to, because it's completely on the side. It doesn't create any side effects, except of some load on the event store when it needs to send these events over. So another thing is that these guys, for example, the command services they can scale horizontally. And why is that? Because they can use optimistic concurrency and they can handle simultaneous requests even for the same aggregate and handle it properly because information over here is fully consistent. So projections, however, cannot scale horizontally that easily because they need to execute events in order. And therefore, every subscription is a linear processing. It's preferably single-threaded, and the only thing you can do there is do async I/O. There are ways to overcome this, but it's out of scope for this webinar. What it could do is basically let these guys run on its own, give them enough resources that can process things single-threadedly, synchronously, relatively synchronously, but fast. But these guys can horizontally scale. So for example, they need to fetch something from the outside world and they can do whatever, and they may be a bit slower, but they can scale them horizontally. We separate them, so this is CQRS full-blown. Commands are handled by one piece of the system, independent units, Kubernetes pods, whatever you prefer, and projections live happily on the other side of the system, but different concerns, different type of Kubernetes nodes, if you will. So depending on the operational requirements, depending on architecture, you might want to split out projections, and building projection on the side is a very interesting pattern. So what else to tell about projections? I was writing an application, but some people say I don't want live coding, so I didn't do that. But I will put stuff in the repo. We promised to put stuff in the repo previously. Just give us a bit of time. We are doing kind of a lot of webinars in a very short period of time, so it takes a bit of time to clean them up and make them work properly and write some documentation. So we will publish them. Just remember to opt in for our communication, otherwise you will miss the email. And there will be working versions. And the version that I was working on now is using MongoDB. So it's a bit more kind of mainstream than Raven, I guess. So one more thing I wanted to tell is about personal data. And this is the last thing I want to talk about. I'm just getting in time, giving it 15 minutes that I missed. No, not this one. So you see my drawing board for the one last time. Here. And personal data is important for people that are in Europe and dealing with GDPR and stuff like that. So, and I, of course, missed my pen here. So imagine that we have a user stream. And maybe we have a customer stream. And we have order stream. And we consolidated all of this into the order overview. That, among other things, contains the first name and last name, and maybe the address, because it comes from this stream. So, and then the customer comes, and we can have multiple of those, different kind of projections, and they leave across the system and stuff like that. And then the user comes, or the customer comes to, okay, delete everything you know about me, because I insist on GDPR, and so we go. And I am not related to projections, but we know that some people just even keep this first name and last name in a customer stream and maybe in an order stream. There are a few ways to handle this, and we have, I think, correct me if I'm wrong, Matt, we will have a blog post about dealing with GDPR and event source systems. But there is a very easy way to deal with that. Well, relatively, one way of dealing with that is not to do it. So don't do it, don't do it, don't do it. Just don't do it. And as a result, you will have projections or read models without any customer or user information can be kept, because that may be user ID, whatever. It's not linked to any private information. If you kill this guy. So you can delete the stream. And after scavenging the events, all the streams or the events will disappear. You can say, in this case, consolidation or aggregation of the information for a single screen is becoming a problem. So you would say that my customer stream projects to a single small read model. This is the customer info. And when this guy dies, you delete that too. And then it just disappears together. As a consequence, of course, if you have an API over here that shows the order info, it needs to fetch the information from two different places. But choosing the smallest evil, you probably want to do that. So you would say, okay, for that particular piece, I wouldn't choose to aggregate data from and include the customer information, private information into my aggregated read model. I will keep it on the side so I can easily deal with the deletion. Because if you spread it out, it's easy to lose control and it will scatter everywhere, and you will need to have a lot of time deleting and moving over and stuff like that. And exporting, because exporting is also not easy. So I guess this is all I wanted to show, and there was no code because I think we got a lot of code previously. If you still want to see code about projections, you want to see me live coding, make a suggestion. So we will be happy to run another one. It just will be a longer break between webinars, because doing it every second week is a bit tiring. So, but still open for suggestions. And now it's question time.
Yeah, I got some questions. So I've been answering some as you can hear me, right?
Yeah.
Great. I've been answering some questions we've gone along, but I've saved some for the end because I wanted to make you miserable. So I'll just run through them. So the first one from Alberto is there anything similar to ACK in Kafka to know when your event was consumed by a certain number of consumers or projectors?
Not as I know that. In Kafka, surprisingly, I was talking about this now. I don't have. I'm not a big fan of that approach because it requires me to know how many consumers I have, and it's not always feasible because we give people freedom. Like you want to create a reaction that will project stuff to you or create something in your bounded context. How would I know about it? So in my view, it introduces a bit of restrictions. So yeah, we usually don't do it, and it depends on the infrastructure, of course, but there is ACK and NAC and PARC in the persistent subscriptions, and we haven't touched this topic yet. It's a bit more advanced about projections that do not require ordered events, which is a completely legit use case. But I would park this for later discussion. So if you can advise something on that, Matt, I have.
Yeah, I got a list of all questions. So good.
Yeah, you know stuff, you know.
Apparently. The next question is regarding consistency on the right side. Is there any pattern to tackle uniqueness or membership in event source systems? For instance, how do you enforce domain invariant? Like you cannot delete an e-commerce category that has products in it. Of course, you can keep the linked products in a list in a category aggregate, but then that would be millions. Do you have any way to work around with flags like has products?
I usually do it. I will create a projection and I would ensure that it's very fast because I would expect product categories not to be deleted very often. So I would say that, for example, as soon as your product category got created and you got one product in it, it cannot be deleted anymore. And if there is a glitch happening that was immediately deleted, having a race condition between adding a single product to just a new category, it's a very, very edgy case, and you can probably deal with that later somehow manually or half manually. On the other hand, if products are being deleted from the category, and then eventually it's 1 minute later that you can delete this category, it's not a problem at all, because especially if you talk about millions of them, so like shrinking from 1 million to 0 probably takes time. So I'd say that particular one is not a big deal. So you just create a small projection and maybe even keep it in memory and flush it to the disk sometimes. So then you solve this. And this solves a lot of problems. Username uniqueness, project number uniqueness that I mentioned, and many cases where you actually need to analyze your SLA. So really look closer to this SLA requirements, and then you will get a lot of insights about solving these kind of issues. And I would not say this is the main invariant. If this is the main invariant, probably we need to do something with aggregates. But this might be something that you request information from outside using domain service.
Yeah, that. Okay. The next question is, if we use persistent subscriptions, which is an event store feature, which have built-in checkpoints, would we still need the Mongo checkpoints?
No, in this case, not. Persistent subscription is a thing on its own. So it's basically server-driven. You have no influence on that. So it moves and it moves. So there are nice features there. For example, the persistent subscription can handle retries for you. And so if you NAC your event just by throwing an exception saying NAC, then it will retry as many times as you said to retry. And you can park them. And you can say after the number of retries, it still needs to move on, but then it will remain NAC'd. So you can retrieve this information from EventStore later. So persistent subscriptions are great. And Kafka uses similar, so they store checkpoint or offset on the server. It's perfectly fine. The thing is that there is, Eve Reinhardt said, okay, keep your checkpoint close to the read model, because imagine your read model went to hell. So what would you do? How would you need to reset it? So if your Mongo database disappeared. So if you keep checkpoint in the same database, it will just catch up eventually, and then it will be new again. If you keep checkpoints somewhere else, the chance would be that eventually you wake up and the read model is completely nonsense, because basically the checkpoint moved, but you missed all the data that was there before because the database got empty somehow. We got it other way around. We were storing checkpoint in Redis for the sake of speed, and one brilliant guy said flush all, and we lost our checkpoints one brilliant night because we also used integration by reading events anti-pattern. We started to react on them, and all hell went loose, and then I don't want to talk about it. So keeping checkpoint closer to the read model is a very interesting pattern. I usually use persistent subscriptions for reactions, because then where else would it store? There is no read model. So this is I would be very careful about it.
Yeah, I'm agreed on that. Next one. How to do the counter then in a proper way with idempotent projections? So, right, okay, yeah. Does that make sense?
Can you say this again?
How to do a counter in a proper way with idempotent projections?
Counter.
Counter. So I'm assuming the question here is that if you're wanting to increment a value within a projection.
Oh yeah, the counter. Yeah, I see. I would say put your counter in the aggregate, because that's fully consistent. So you can do, as I told you, like there are ways of doing that. Getting from the subscription the current position and putting in the read model, and then saying you cannot project any event that's behind it. So this can be used, but it depends on your structure. So you need to take care that you have this information in place. So a checkpoint in the global stream gives you the exact position where you are. And if you put it in the read model, you kind of save. So you just say everything that's below that, I ignore. So you can do it. This is one way of doing it. So if you absolutely must, you can do it this way.
Reading that one. And then, oh yeah, not strictly event store related, but what whiteboard are you using? The drawings are better than most I've seen since the pandemic hit.
Well, I have no idea what it said.
The whiteboard tool that you're using.
Oh, it's Samsung Flip.
Say that again?
Samsung Flip.
There you go. Next question. If you're using distributed cache like Redis for checkpoint storing and maybe backup retries, does horizontal scaling become safe for projections?
No. Horizontal scaling doesn't have anything to do with checkpoints. Checkpoints just tell the projection. It only is relevant a single moment of the life cycle of the sort of execution runtime of the projection when it starts. Everything else it does is just shovels it in the storage, would it be cache storage or persistent storage, just for the sake of getting it later when application restarts during deployment or pre-provisioning nodes in Kubernetes or whatever else. So all of this work, just keeping it just for the one single moment of time when the projection starts and read it, so it knows where to begin again. So I already mentioned Redis. So Redis is very nice. It has operations called flash all, and you never know who accesses your Redis cluster, so be careful with that. Second, then again, I mean, if your projection is idempotent, it doesn't matter. You can batch or ignore several checkpoints. You just say, okay, I write checkpoints every time, every 10,000 events. You can save some I/O, but you still need to write your read models. You can batch read models as well if you have better SLAs. So if your store can update multiple documents at once or multiple rows, so you can do that. You just get a little bit of gap, so it just flashes like every second, but it flashes a lot of information. So it's not about horizontal scalability still. It's about horizontal scalability is needed to ensure sequential processing of events. Because if events come out of order, some projections can be screwed. If you don't have this issue, you can use horizontal scaling. Doesn't matter where your checkpoint is. You can use persistent subscriptions. You can use message brokers or whatever. You can use competing consumers. So, but it requires certain properties, operational properties on the projection. So it doesn't care about ordering of the event. And then one particular example of that the event contains the full information that overwrites everything that's in the read model from before. And then you save. You just can, you look at the timestamp and say, okay, last update later than my previous one, update. before than the previous one, ignore, and then you save, and then you can scale horizontally like hell.
Okay, the next one's a good question. Any ideas on how to fix errors in a stream because of bugs during development? I understand you might want to compensate for real scenarios, but I don't want to write compensating code for invalid data in a stream. Restoring a backup without the contaminated streams is a solution, but not always convenient.
Yeah, there is no good answer for that, except this is, in my view, this is one of the major kind of barriers for people that are coming to EventStore, because again, in the article I mentioned at the start, the author mentioned that, yeah, we go to production, run some update query, and then everything is fixed. I think this is a famous article what they don't tell you about event sourcing. And although I agree with half of what they're saying, I don't agree with the other half, because I've seen people doing SQL queries in production that kept people woke up for the whole week. So open heart surgery, as they used to call it, is also dangerous. So yeah, I would say compensating actions is another way of doing this. It's a safety net for you as well. It sounds tedious, but to be honest, running EventStore system for years in production, we really rarely see that kind of stuff happening, to be honest, for some reason. There is a hack, though. So you can hack your read models, but just manipulating it. So you made a miscalc. You just write a script that updates them and keep them going further on, because you guarantee that the events that are coming from that moment on are correct. And then somehow you manage to compensate and rewrite the stream or add a compensating event to the stream or another stream. So to keep your system alive and available to the customer, you can hack a read model like that, just as traditional database, because you just need to manipulate the states and deal with that later. It gives you time. So yeah, but I agree. So it's a good one.
Then 2 more to go. Interested in how to speed up the ordered serial processing. Is that another session?
Yeah, I have some ideas, and apparently the most obvious one is buffering. So if you're, as I said, if your store excels at batches, like I know that Elastic does much better performance of indexing, not indexing, but accepting documents when you use their batcher, and it does crazy stuff, paging and things. And if you do it one by one, it's really bloody slow. And if you do it in batches, it's very fast. And the search in particular is a very good example of that, because nobody expects search to be available in like a single instance. People tolerate, because they know that things, page in Google takes months to appear, probably, in search. But, and in this case, there is the SLA is quite relaxed, so you can batch. There is another way, and I had us talk before on a couple of conferences about using actor model, because then basically your read models remain in memory, and they can scale a hell, because especially if you use a cluster of actors, because then you have the single point of entry still, and this is your single subscription. But the subscription doesn't do much than just sending it out to the actor model, and they take care. They don't need to read anything. They don't need to maybe even persist anything. They keep everything in memory and shovel from time to time to the database, just for the sake of retrieving it faster. But the prototype that I started to do has never been finished, because I like to do dogfooding. So if I don't use it, then I don't do it. But my intention is basically fix it and one day do it. I know that FlixBus is doing that. I talked to a colleague about that at Kandinsky conference. So this can solve a lot of scaling issues. I know that James Nugent has some ideas about also keeping stuff in memory, which is a very legit pattern, to be honest, because memory is not as expensive as before. And some data sets can just stay in memory and shovel to disk from time to time. Again, this is not batching, it's just delayed writes and maybe skipped writes. So you just ignore several events for the sake of catching up later if you want to, and keep in memory, and this answers you the query straight away, and it's very fast.
Okay, and then the last question, which is, how would you suggest handling checkpoints with a projecting event source state into a read model when it errors, incrementally retry with buffering of events that come in?
Well, basically, if you can only solve transient errors, you cannot solve the permanent error that actually influences you right to the database. For example, you have a problem that the document or table to compose is incorrect. For example, you have a nullable field or non-nullable field and try to write nulls. It never goes to solve, no matter how many times you retry. So you need to be careful on that. So you need to apply a retry policy. You cannot try a retry policy saying that if it's a network glitch, I will try again several times and maybe even stop the projection. And then I will move on only when everything is fine. But you need to carefully distinguish database problems that are recoverable, network problems that are recoverable, from unrecoverable problems that are inherent complexity of your projection that can't be just recovered because the event is invalid. That's basically poison message. This is the patterns from normal messaging enterprise integration patterns apply. So poison message, put it in the poison queue, and then you move on. And in this case, you never slow the projection. So you have poison message ignored. So, and trigger an alarm saying, I don't know what to do. So, but then, so if you screwed up one customer in your system, you probably don't want to screw all of them. So just move on and deal with that later.
Cool. And Adam Dimitrik has snuck in one question at the very end, which is basically, he's saying, can you talk about replacing projections with querying the stream directly?
Yes, I can. There is a talk made by Greg, and it's good. I think he explained it much better than I do, and it's called EventStore, not just for command model or whatever, also for query model. So the idea is that your read model is nothing else than a representation of state over a certain entity and at that particular moment in time. So this is how read model in any database is formed. So you can write a projection in EventStore in JavaScript. Hopefully there will be more languages. I don't want to talk about this now. Create a new stream, which will be a current, and you can set a TTL on that stream saying max count of that event is 1, and it will be always a snapshot of the latest state of your read model. The problem there that you can't reach out to other streams. Correct me if I'm wrong, Matt. Can you read other stream from projection? Don't think so.
Don't ask me on that one.
Okay. And so it's harder to do aggregation. So you need to listen. Well, reaching out to another read model is probably not the best example because if you aggregate it, fine, you got all the events from different streams, entities, and you're good. The only issue there is, first of all, it produces load on the EventStore cluster, and I know that's not ideal how it's done now. I would say I've seen things done when this kind of projection damage the system performance really hard. Second thing is that it's appending only. So again, even if you set TTL on one event on the snapshot or current read model state, it will append all of them. It's just you don't see it because it's how EventStore works. Only when you scavenge, the historical ones will be removed. So it's quite a lot of burden on persistence. And every event you receive will force EventStore to write one more. So it could be lots of writes, and you might not want this because your EventStore cluster is under load anyway. One more issue with that is that these things do not query still. So if you want to put a query on top of that one, you need one more. So you need to listen to all the snapshot streams and combine another one to have a new key. So if you put stuff in Mongo, what it takes for you to basically query by something else, which is maybe not the best way of doing that, but sometimes you have to, because I've seen that, just put an index, and then you start a query, and it's fine, it works. EventStore is a key value store in that regard. I mean, you can just query a single bloody stream, and this is how it is. And if you want to query like across multiple events, across multiple streams, it could take time. And this is probably not the best way of dealing with the place where you write your business events. And so, yeah, performance could be hit by that. But it gives you much better SLAs because they basically are almost transactional. They're not, but almost.
Cool.
and it always run on the server.
That's it.
Yeah, and they don't trace, right? So you don't have a flame graph. You will need to monitor them from EventStore APIs by looking at the stream and this particular projection states and stuff like that. So it might be tricky. So be careful.
That's all the questions.
All right. Cool stuff. Sorry for technical glitches, especially me walking away and using wrong mic and stuff like that. And I don't know if I need to apologize or be proud of that I didn't do any code this time. I just want to do something else. And I promise you that the next webinar will be completely different. And I have no idea what it will be. But we can, if you have suggestions what to talk about, just let us know. Thank you very much.
Thank you.
Bye-bye.